Welcome to a new episode in my home automation, OpenHAB and Node-RED series. As you can see from the video, I have an FTDI programmer out and a Sonoff. So yeah, you guessed it right. Today we are going to flash the Sonoff with another firmware. Previously I've used ESP Easy and Espurna, and this time I'm going to use Tasmota. I believe these are the three most widely known and commonly used custom firmwares for Sonoff and many of the other ESP devices. I started using Tasmota a couple of weeks ago, and I can definitely tell that I'm only starting to scratch the surface. So in this video I'm going to focus on the basics. I will show one method how to flash the Sonoff, and that's not the only method. And I'm going to show the most fundamental features, how to get started and how to get it running and integrated. Again, I'm going to use Node-RED just to simulate the MQTT and the HTTP communication, but again, it works with many other systems, OpenHAB, Domotits, and even more. If you Google Tasmota, the first link, non-advertised link that you're going to find is a GitHub page of Sonoff Tasmota, and you can see some information here and all the different devices that are supported by this firmware. But what I'm going to do here is go into this, click on this wiki link, because here you can read so much more about this. And just by going through this list and seeing the topics here, you can pretty much tell that this is a really extensive firmware for Sonoff and the ESP devices, and it can do quite a lot, and it has a lot of features. As you can see in the home automation integration section, you have OpenHAB, Home Assistance, Home Bridge, Smart Things, and some of the other setups. And again, I highly recommend to bookmark this if you are planning to use Tasmota, because there is pretty much everything you need to know is here. I've also mentioned this on my previous videos, but for anyone who is new to this firmware refreshing and what is FTDI and how to create the pin headers on the Sonoff, I've created a separate video, and you can find the card for that video appearing now. So if you need that basic information, then you should watch that video first. Any programs that I'm going to use in this video or links to the examples are in the video description. So first thing first, we need to connect the Sonoff to the FTDI programmer, and I have this Sonoff cheat sheet document where I just keep all the main connections documented and everything you need to know about Sonoff Basic, and using that I'm going to connect. So the innermost pin, the one closest to the button is 3.3 volt, and then next you have, I think it's TX and RX, so two of the serial lines, and then finally ground. And you will see later on that if you have any issues with programming, your programming doesn't start, you most probably have the wires, the RX and the TX lines swapped around. And also wanted to mention that just today I got a comment on one of my earlier videos saying that soldering these pin headers to the Sonoff is an actual, it's a bit of an overkill, because the original board has these connections, so it's like empty holes. And so he suggested that you can also use these these are the male pin headers, and just stuck them into the holes and then tape them down, just to make sure that they make enough connection, because the flashing only takes a couple of seconds. So if you have the connection good enough for those couple of seconds, you are good to go, and then you can remove it. So you can save yourself from the trouble of soldering these pin headers. But these things move around, and I just like this better this way. But again, you don't really have to. So to start the flash process, just like with any ESP device and with the Sonoff, we need to get the GPIO 0 to ground when we are plugging this in, and the GPIO 0 on the Sonoff is this push button. So just push it down, make sure that you hear the click, and then you plug it in, and then you let it go. And so this button has this really high plastic thingy on it, and sometimes it's difficult to push it down. So just make sure that it's pushed down, and you can hear the click when you are pushing and when you are releasing as well. So now it is connected to my laptop. Yep. And we can start the firmware update. Well, first of all, we need to download, and here again in the wiki you can find the upload tools. As you can see, there are many different ways to upload the firmware, and I'm going to use the ESP tool because I think this is the easiest way to do, which doesn't require installing any additional software. So it tells you about how you can download the ESP tool, which is in a Python program, but and you need to download the Python and install it. But I do have the exe file. I put it again, the link in the video description, so you can use that. All you need to do is you need to download the release, the latest release. So you click on this link, it takes you to the releases, and as you can see, at the moment the current firmware is 5.10.0. And then you scroll down and you find the downloads here, and you need the sonoff.bin. So you click there and then just wait until it downloads. I have already moved these files into a separate folder just to keep them in one place, and I just renamed the Sonoff to Tasmota.bin, so the Sonoff bin to Tasmota bin, but actually these two are the same files. So for writing the firmware, we are going to use the ESP tool. So I'm going to start a command line here. Start a command prompt in Windows, and then make sure that it points to the same folder where you have the bin and the ESP tool exe. And I have also save the actual command for myself, so that's the command that you need to issue: esp.exe/vv/cb 115200. So that sets the communication speed, and then cpcom7, so that's the COM port for the FTDI programmer. So mine one is on COM7, so that's the starting address, which is 0. BZ 1 megabyte, so that specifies the memory size of the memory chip of the ESP, or the memory chip that is with the ESP, and for Sonoff it's 1 megabyte. And /bm it's D out, so that's something that was specifically in the documentation, and I believe I read it somewhere in the Sonoff documentation that will allow you, so that's the out option, would also be used in the newer version of Sonoff, and it also works for the older version of Sonoff, so just include that one. And then cf Tasmota bin, so that's the file name for the bin file. So I'm going to copy this one and paste it in here, and then execute, and you should see the setup process, or the flashing process starting. So you see the dots going through the screen, and it's going to take about probably about half a minute for this flash to be loaded onto the ESP. As you can see, the flashing of the ESP has now completed, and it says that the device being rebooted. But just to be on the safe side, what I like to do is I just unplug it and plug it back again, so the power cycle the whole ESP. And also in my previous video, I just suggested that once you have done with the flashing, you can just remove the cables and put the ESP back into the normal enclosure, and then run it from the mains power. And that's actually it's a good idea, because some devices and some of computers, USB, or the programmers may not be able to provide sufficient power for the ESP to run. So it's always a good idea just to run it from the mains. Okay, I have the Sonoff connected to the mains now. I haven't connected anything to the output, so you just have to believe me that the relay is working and it's actually switching, but it does. And just like with any other firmware, because even without doing any configuration, clicking on the button actually operates the relay. So yeah, the firmware knows that it's running the Sonoff, so it knows which pins the button is connected to and which pin the relay is connected to. And in the meantime, I've gone back to the wiki, and on the side in the navigation I selected this button functionality, because this explains the different functions that you can activate by just simply pressing the button. So obviously one short press will toggle the relay, and then you can have 2 short presses, 3, 4, 5, 6, 7, and they all do a different things. So what we want to use is you can use these 3 short presses and do the configuration using an ESP8266 Smart Config app. But what I'm going to do now is I'm going to use this second option, which is the 4 short presses, which then activate the ESP8266 to create an access point, so you can connect to that Wi-Fi and you can do the configuration on the ESP. And by the way, there is with 5 short presses, there is another mode. If your router has this WPS button, then you activate that pairing by 5 presses, and then you press that button on your router. So I've never used this functionality, but that could be quite convenient as well. But you would need you would need to do some additional configuration anyway, so probably it's just easier to do the 4 short presses and do it on the website. So to activate the config mode, I'm going to do the 4 short presses, and you have to press it rather quickly. So 1, 2, 3, 4. And then what you should see that the status LED is now blinking. And by the way, it also says that the link will blink during the config period, and any single button press will abort this and then restart the Sonoff. So if I look at the my wireless networks, I can see a new wireless network. It's an open network which is being created, and actually this is called Sonoff 5 and then dash something. For a brand new device, it's going to do ESP, but to be honest, I have done this whole configuration before making this video, and so the Sonoff actually remembers some of the settings that I made earlier. So, and I've already named that to Sonoff 5, but again, by default, it's going to be ESP. So let me disconnect from my preferred network and then go over to this Sonoff one. So you connect. And then once you connect it, then you load this address. So it may take a few seconds for the web page to load, but when it does, you should be presented with this screen, and that's to do the basic wireless configuration, and that's all that you are going to do here. And you can scan for wireless network, but you can enter your the SSID of your Wi-Fi here, and then the password here. And the nice thing about this firmware that you can actually specify 2 access points, and that could be useful if you have I don't know, if you have a bigger place and then you have like 2 routers for different parts of the house, and if they are using different SSIDs, then you can configure both of them, and once you move your device around, you can make sure that it can connect to any of them depending on which one is stronger. So again, I'm just only using specifying AP1 SSID and password. I'm leaving the second one on the default values, and yeah, that's it. You save and then you restart. So once your Sonoff has connected to your home network, you should go to your router's administration page or download an app like the Fing, F-I-N-G, which can scan your network and find all the devices. So I was able to find out that this device gets the following IP, so 192.168.1.129 in my particular network, and if you load that IP in the browser, then you can see that it's a Sonoff Basic module, and if I click the button, you should see the status updated on the screen, and you can do it also from here. So you can toggle it from using this button, and it works. So we are definitely controlling and seeing this device. So you can click on all these different stuff like the information. You can see some stuff on the actual firmware, the memory size. It's not really that interesting. But first, what you need to do, you need to go into the configuration. I'm going to go through each of them, but it's going to be fairly simple. And what you would notice here is that the Tasmota firmware has a lot of features, and most of these, and only the most essential features, are actually within this web configuration, because All the other features you will be controlling via MQTT, and we are going to go through that later on in this video. So the configure module, what you see here is you can select the actual Sonoff version, well, not even Sonoff, but all the different devices that are supported by this firmware. So we are just going to use Sonoff Basic. I leave all these others on default. We are not going to use the serial in and out and the sensor for that particular module. We have seen the Wi-Fi, so you can change the Wi-Fi configuration here. MQTT, again, you specify your MQTT host, port, client, which is going to be the client of this device. I again just left it on this, the default one. User ID and a password for your MQTT server, and then the topics for the MQTT. So I named the topic as Sonoff 5, so that's my 5th Sonoff device. So that's the topic, and then you have also the full topic. And what is unique about Tasmota, that for most of its messages there is always, well, sorry, not most, but all of these messages, there is not only a topic, but then there is also a prefix. So we will see that this prefix can be like a command or a status or a telemetry, and so it's like a fixed, it can be any of these three. So the default one is, the default full topic is like prefix / topic /. So that means that, let's say to control the relay, I would need to issue a command, or sorry, I need to send a message to a topic, which is like CMND for command / the topic, which is Sonoff 5, and / power, and the value of the payload is going to be on. So in this particular arrangement, the prefix is before the topic, which could be a little bit confusing, but you are free to change this around. So you can have this to percentage topic percentage / prefix / if you like that way, and then your topic can be anything like let's say /home / bedroom / light, and then with the topic being in the beginning, so you can address this device like /home / bedroom / light / command / power and payload on. But for this video, I'm just leaving this all default. So the topic is Sonoff, and I would have the prefix before the topic. Good. That's all about MQTT. Not going to go into the Domotic's integration, and I don't have Domotic, so I don't really know about this stuff. So you can find it out from the wiki documentation here. Where is it? Right here. Logging, yeah, I'm not really using this one as well. You can probably this weblog could be useful, so you can see it's only so it shows it's like set to medium, so you're getting quite a few messages, but not all of them. If you have issues, you can probably turn it into more debug, and you will see. I will show you what impact it makes within the firmware. And the other thing which I also want to highlight is this telemetry period. Just like with Espurna, your device is going to send out information like its network strength and the IP and the time and some other details at a set interval. So that's the telemetry period. So it's set to 300 seconds, so that would be, I think, 5 minutes. So every 5 minutes you would get this data automatically. If you want to increase or decrease this period, then change this telemetry period here. So that was logging, sorry. Configure other. Yeah, you can have a valid admin password, friendly name. Haven't changed this one. Again, important things for people who are planning to use the Tasmota for a specific integration, that this is where you turn on the back-in vMo or the Hue bridge emulation. So it's a nice feature that is unique to Tasmota. And then that's it. Yeah, you can reset, backup, and restore the configuration. When we go out of configuration, so that was configuration information, just information screen. You can update the firmware here. So we just have the newest one, so we don't care about that one. And then finally we have the console, and that's actually quite useful. So, and that's the, so when you previously in the logging, you set the log level, the web log level, so that influences what you can see here. So it's set to medium, and what is set to medium? So it's set to like the medium level. And what you can see here is everything which goes out to MQTT. You can see it here. So that's again a great debugging tool to see what's messages being sent out. So you can see these telemetry messages. So these are the ones which are sent based on the telemetry period. And if I keep pressing the button, then you can see the corresponding messages of the power state going in and out. And we can enter a command here, and again that's something that I'm going to talk a little bit later, what are the different commands that are supported by the firmware. But that's pretty much it. So that's the basic configuration. Again, to get going, you set the Wi-Fi and you set the MQTT details, because again, this firmware is mostly designed around MQTT. Not exclusive, not only MQTT, but it's mostly MQTT. And now it's time to look at Node-RED and see some examples how to control this device. As I mentioned previously, whenever you are talking to a Tasmota device via MQTT, you not only have the topic, which is Sonoff 5 at the moment, but you also have a prefix. And that whole concept is described here in the wiki if you click on the MQTT overview. So you can see the different communication that is going back and forth between the device and the MQTT broker. But a little bit further down, you can see these 3 different prefixes. So the first one is CMND, that's the command. So that's when you are issuing some commands to the device to, for example, turn on the relay, turn off the relay, toggle the relay. And we can see that there are a lot of other commands where you change configuration using MQTT. Whenever you issue a command, in most cases you will get a status message back. So you toggle the relay, you will get a status back whether the relay is now on or off. And then you have the telemetry messages, and one example of the telemetry message is the status information which gets sent. But if this wouldn't be a Sonoff, if this would be like a Sonoff POW, or it would have a temperature sensor assigned to it, then the same telemetry message is going to report back the temperature, humidity, and voltage and power readings. So that's what the telemetry message is used for. There is a diagram and the flow here which explains the communication in detail, but let me just go through it in this example code. So here what I have done is I have subscribed to all the status and the telemetry messages. So again, stat/sonoff5/hash, so everything, and then again tls/sonoff5/hash. And some of these messages are coming in simple text, and some of them are in JSON format. So in order to display them correctly, what I've done here is just I created this very simple switch which checks whether the first character is a this bracket. So I know it's JSON. So if it's true, then I convert the JSON to a JavaScript object. Otherwise, I just display it in the payload. So that's just to make sure that it can be displayed correctly. So at the moment, we don't really have anything. And if I press the button here, you can see 2 things. So I have one status message, which is stat.sonoff5.power. It equals on. So I know that the relay is on. But I also have a result message which says that I change the power to on. So you can use either of these to get the status. And if I press it again, then I get this power off, power off. So I know that my device is off now. And if I want to get the status, I can also get the status by sending a command to command/topic/status, and I will get multiple status messages back, and they are all coming in a JSON format, and they would have a stat, topic, and status. And you see that it is an object, and it contains different states, and there is a status 1 object which contains some other stuff like uptime and sleep and boot cycles, and then the status 2 contains information about the firmware, and then status 3 contains information about logging, and then memory, and status 5 all the IP settings, so the network settings, and the MQTT settings, and what is it, time, and not sure what SNS is, and STS is again something else. Oh yeah, again uptime, VCC, and then here you have some power, the Wi-Fi information. So the SSID is connected to, and the RSSI. Funny enough, in all other firmwares, the RSSI is usually a negative value between -50 and -100, and it's a positive value here. I'm assuming this is a percentage, so it's like 72% of the maximum Wi-Fi strength, I'm guessing, but I haven't found any information on that. So that's the way to request status back from Sonoff. And then let's go to the simple controlling. So you have all the functionality that we have seen here. So you can turn the relay on, you can turn the relay off, you can toggle the relay, and there is also this weird function which is called a blink, which, as you can hear, it's like on-off in a 1 Hz cycle. And you can't really control whether it's well, I couldn't find a way to control the on-off cycle, so I don't know what this blink is designed to be used for. But anyway, so if I issue off, then the blink also switches off. And now what we can see is that we have received one of our first telemetry message. So probably 5 minutes has passed since it was booted, or since the last one. So we can see that the telemetry message looks like one of the status messages. So we see the current time on the device, the uptime, the VCC, and then again see that what wireless its network is connected to, and the RSSI and the MAC address. So yeah, so that's the thing that you are getting every 5 minutes. Let's go back to the HTTP control. HTTP control is also fairly similar to what we have seen in Espurna, and again, if we go into the usage, we do into supported commands, then then you can see that the commands need to be formatted in such a way. So it's the HTTP : the IP or the name of your device, CM ? CMND equals, and then you get the par, and then space and the value. And the really nice thing is that when we talk about the commands, these are the commands which work exactly the same way in MQTT and also in the HTTP. So the MQTT, you know that the topic includes again the prefix command and then the topic or the name of the device, and then the last parameter is the command. So if I go back, it's command Sonoff 5 and power, or status. So these are the commands, and the exact same commands also work in HTTP, and then you just put a space and then you put the payload. So here you can see that it's power, and the payload is either on, off, or toggle, and exactly the same way, exactly the same stuff works in HTTP as well. So HTTP, the IP CM ? CNMD equals power space off, or power and %20 off. And to on, you just power on, and then toggle, it's power toggle, and we can get the status as well. So that we use issue command status. So if I clear this, oops, what did I do? So if I clear the debug window, so I issued an off, I get an MQTT back saying that, oh yeah, we just issued off. I can do an on, I can do a toggle, and I can also request the status, and I get the status back in MQTT as well, but I'm also getting back the status in the HTTP as, again, a text, which looks like JSON, but because it has the status equals in the beginning, it's not exactly JSON. But so again, I just wanted to show that all the commands that are supported by a firmware can equally be used in MQTT and also in HTTP. So some people also requested that I put a simple UI flow together, and so this is what I have done. Again, that's how you would control the relay with a simple switch, UI switch. And that's again really simple, because you specify that the on payload is on, the off payload is off. And then the output goes into, again, the command topic, which is command /sonoff5/power. The toggle would be exactly the same, the payload will be toggle. And I put a separate button for on and off as well. So toggle works like that, and you can have a separate on and off. So at the moment it's all working on MQTT, but you might as well just do the same with HTTP as well. And to display the status, whether the relay is on or off, I have created a subscription for stat_sonoff5.power, and that goes into a template node, and then basically displays either an on or an off word based on whether the payload is on or off. You can see it here, and again, if it's on, it's blue, otherwise it's gray. So simple as that. One thing, I mean, I know we are talking about a Sonoff, but if you would have like a Sonoff Dual or a Sonoff 4-channel one, then you can use power 1, 2, 3, or power 1 and power 2 for Sonoff Dual, and then power 1, power 2, power 3, and power 4 as a topic in for the 4-channel Sonoff. So it's similar to similar to the concept of what we have seen in Espurna, I think. Next feature I wanted to highlight is there is this pulse time. So you can set a pulse time value, and it can be a number from basically 0, which says that the pulse time is off, to a number which is 65,000. And if you set a really low value, like from 1 to 12, that will be milliseconds, and anything above 12 is going to be seconds. So I just moved the slider a small bit. So now you can see that the pulse time is set to 10. And if I turn it on, then it turns itself off, on off. So using this pulse time, you can configure this Sonoff to be an off delay. So you turn it on and it will automatically turn off. And if I put like a really high value, and if I turn it on again, so that will probably take like a minute or two to turn off. And no, actually it was quite, it was quicker. What was the value? 66. Oh, that's about 6 seconds. I don't know. It's a little bit weird, but again, we are going through the command that are supported. And again, if you come into the wiki and then you click on the supported commands, you can see all of these here, and these are huge. I mean, you can see it's everything that the firmware is capable of doing. You can change them in configuration, like by sending MQTT messages. So I just picked the one which is sorry, let me just find this pulse time. So I was just using this. So if you send a pulse time between 1 and 111, so 111, so you set the pulse time in a 0.1 second increment. So sending 6.6, that will be 6.6 seconds. But if you send a value above 112, then that would be seconds. So 113 is going to be 13 seconds. It's a bit confusing, but I guess you get the idea. So again, you can use it for a simple off delay, sorry. And the rest of the flow here is related to the telemetry message. So I just subscribe to the state telemetry message. It comes in JSON, so I just convert it to JSON, and I strip these pieces of information out. So you get the uptime out, I get the RSSI, which is getting displayed in a chart, and I also save the last time I have received. So here I store the last time when this message is received in a global variable, and then I execute this inject, which executes every second, and it just basically calculates how much time has elapsed from the last update. So, and that's also being displayed on the screen, so that should go up to like 5 minutes, and then it's resets when it receives a new message. So again, that's based on the telemetry period, which we have seen in the config. So basic control, basic controlling of the relay, switching, toggling, turning it specifically on and off, and using the pass time to turn it as an off delay. And if you set the pass time to 0, then it goes back to normal, like always on type of relay until you press the off. And I think that pretty much constitutes the basic configuration and the basic setup of this device. But again, what I want to show is just how much more information is available in the documentation. And if I go back to again the supported commands, the commands are grouped in sections like the main and the management and sensors. So you can see that only in main there are so many different stuff. And so what you see here is the command, and then you see the payload that needs to be sent. So again, just remember that. So that needs to be the prefix / topic and then / the command, and then the payload is whatever is here in the documentation. And then usually if you just send the topic without any payload, then you will get the current value back. If you are set with an actual payload, that value gets set. So, and you can pretty much control anything, or you configure anything from here. So for example, you can specify whether the status LED is going to blink when the MQTT message is sent or received, or where it's going to be blank where it's going to show the status of the relay, and whether the power and state of the relay should be on or off, or toggle of the previous state, and well, the pass time that we have seen here. There's all sorts of options that you can set, this different switch mode to control how this button is going to behave. I'm going to skip the entire sensor section because the Sonoff Basic doesn't have any sensor functionality. The management is again, there is all sorts of stuff here, which probably is not too relevant for the Sonoff Basic. There was one, this interesting functionality, which is the sleep functionality. And what you can do here is you can send the Sonoff to up to a 250 millisecond sleep to save energy. And during that sleep period, it's not going to respond to button presses. But if you send an MQTT message, obviously it will get picked up when the device comes back from sleep. And it is also documented here. So if you go back to the contents, there is a section here on low power or power saving mode. Yeah, energy saving. And I have to tell, this is quite a unique function. It's quite an interesting one. And if you look at this, you can reduce the power consumption from 1.1 watts to about 0.4 watts. And if you have many of these devices, this actually adds up. So I haven't seen this concept in any other firmwares. Maybe I wasn't looking hard enough, but that's quite a neat thing. So let me go back to the commands. So I'm just going to show you what you can start thinking about when, why you should consider using Tasmota. Again, you can set the logging, the different logging parameters. There are some specific stuff for the POW and the different light like LED bulb devices, and yeah, the addressable LED string, the RF module, don't want it. That's also quite nice. Maybe I'm going to play around with this in the future, so you can send infrared commands. I wanted to look at the management section. I think there is a management section because yeah, so that you can also change the MQTT settings via MQTT. Yeah, interesting. But the other thing is this management one, or the Wi-Fi one. So we have seen how you set up the basic access point, the hostname, the SSID and the password. But let's say you want to have a fixed IP address. So the only way to set this up is then you do the basic configuration. It would receive a dynamic IP address, and then you start configuring it via either MQTT or HTTP. So you can see that by supplying your IP address in IP address 1 topic, and then in the payloads supplying the IP address, you can set it to use a specific IP address, or if you do 000, you can set it back to use the HCP. So again, that could be really, really important if you're planning to use it with HTTP, because it's much easier if it has a fixed IP. And not to mention, there is all sorts of other things that you can also set here, the web password. And so some of these we have seen in the web UI, but again, there is a lot more here which you can't set via the web, only here. And same applies to MQTT and others. So if you want to explore a little bit more, again, just spend some time going through the documentation here under MQTT features. And also the other thing I wanted to mention, I'm not going to cover here, is there are some other ways of uploading the firmware. So there is on the over-the-air update, the platform IO, and also the Arduino IDE. And so if you use these two, so the Arduino IDE or the platform IO, you can download the binaries as well. And what I wanted to highlight here is that if I look at the Arduino code, for example, sorry, it's not here. It's here. In the source code, you will find a userconfig.h file. And the userconfig.h file is basically a configuration file where you can set all the parameters that you want right up front when you upload the firmware. And I haven't gone to this option because I think it's, most of us probably can do it on the over MQTT, or just follow the steps that I've shown here. But if you are configuring devices for someone, or if you are creating many of these, this is probably a very nice and easy way to flash your Sonoff, and then flash it with specific settings which are ready to go. So you flash your Sonoff video settings, and all you need to do is just to plug it in, and then it's going to go. It would know the Wi-Fi settings, the IPs, the MQTT settings. So it's a very nice and easy way to set it up for a known environment. As you can see here, you can set the IP addresses, SSIDs, the logging details, the MQTT settings, everything is here. So that's available if, for example, if you are uploading it via the Arduino IDE. And by the way, there is a fairly decent documentation for each of these options, what you need to do, how what are the different settings that you need to set in the Arduino IDE to upload it. And also, I've mentioned this before in the beginning of the video, but there is this section on the home integration. So that again nicely explains how you can do it. I mean, most of it is done via MQTT, but at least, for example, within the Open Hub, you are getting actual examples how you set up, your items file for a Sonoff Basic and a Sonoff POW, and also you're getting some nice features here. So you can have this UI element on Open Hub that you can remotely restart, upgrade the firmware using the OTA settings. So again, you will find the items, the sitemap, and the rules files here for MQTT. For Open Hub. And equally, there is a good documentation here for some of the other things. And I can see here some, I mean, home bridge and smart things, which well, maybe I'm wrong, but I think that's unique to Tasmota again. So that could be one more reason to use Tasmota over two. I think that would be the end of this fairly extensive Tasmota, Sonoff Tasmota video. I say fairly extensive, but still I think I'm just starting to scratch the surface of Tasmota and what you can do with it. But hopefully this was informative enough and it was enough to get you going. Thanks for watching, and hopefully see you in the next video.